Bill buys a bag of sweets, of which 6 are red, 4 are green and 1 is blue. He selects 3 sweets at random, without replacement, from the bag. Calculate the probability that his selection contains A. 2 red sweets and another sweet of a different colour. Okay, so let's have a look at part A. We want to do the probability 2 red, and now the important part of this question is how you think about the question, because I could do 2 red sweets and then think about picking 1 green and then picking 1 blue, or I could do 2 reds and 1 non-red, so red complement. This makes life easier because then I don't have to do 2 separate probabilities. All I have to do now is say, okay, how many different ways can I calculate picking 2 reds from 6? And this is 6, choose 2. And because this has to happen with another event, we're going to multiply it by the number of ways that I can pick 1 non-red from these 4 green and these 1 blue. So that's 5, choose 1. This is all over the number of ways that I can pick 3 sweets from the 11. So that is 11, choose 3. Once I've identified that, I can put that straight into my calculator and calculate this in one go. This comes out to the answer of 5/11. Remember, to leave this as a fraction, it's an exact answer. You can give it as a decimal, but you need to round, etc. So why not just use the exact value? How do we get our marks in this question? Well, we're actually, for this stage here, we get both a method mark and an accuracy mark for this correct calculation, and then finally for our answer of 5/11 we get an accuracy mark. Let's look at part B. Part B says find the probability 2 sweets of the same colour and another sweet of a different colour. So we're doing probability 2 the same. Well, part A actually helps us along the way with this. What we're actually calculating here is probability of 2 red and 1 non-red, or 2 green and 1 non-green. Of course, we can't get 2 blue, so that's where we stop. Okay, so how do I calculate this? Well, because we're doing OR, what we're actually going to do is we're going to do the probability of 2 red and 1 non-red plus the probability of 2 green and the 1 non-green. So I'm just going to calculate the probability of the 2 green and 1 non-green separately. Just break it down a little bit. So 1 non-green, exactly the same way as we did before. So how many ways can I pick 2 green from the 4? Will be 4, choose 2. Multiply, because we then have to also pick 1 non-green. The number of non-green is 7. So that's going to be picking 1 non-green from the 7 non-greens, all over the number of ways that I can pick 3 from 11. When I put this in my calculator and work it through, I get 14/55. This means, to finish off my calculation for the probability of 2 the same, what we're going to do is we're going to have 5/11 plus 14/55, and when we complete this sum we get a probability of 39/55, and all of these should be just left as fractions because they're the exact answer. Okay, let's see how we awarded marks in this question. Well, first of all, we're going to get a method mark and accuracy mark if we have got the correct calculation for calculating the probability of 2 greens and 1 non-green. We're going to get an accuracy mark for calculating an accurate answer for the probability of getting 2 green, and then we are going to get an method mark for correctly identifying that we're going to need to add the probability of 2 red with the probability of 2 green, and finally we get an accuracy mark for identifying the probability of 2 the same is 39 out of 55. Okay, well I hope you understood that all and that it made sense to you.